Hello everyone, I am Praveen LM. I am studying in first year MSc Chemistry in Jesus College of Arts, Commerce and Science, Ooty Road, Mysore. Today I am going to explain the topic about fluorescence spectroscopy in analytical chemistry. For the first, we come to know what is fluorescence spectroscopy. Fluorescence spectroscopy is a type of electromagnetic spectroscopy that analyzes fluorescence from a sample. Then we move on to the principle of fluorescence spectroscopy. The principle of fluorescence spectroscopy based on the Jablonski diagram. Then the instrumentations of fluorescence spectroscopy. There are different components are present in fluorescence spectroscopy. Mainly there are 5 components. The first one is light source. The second one is monochromator. In the monochromator, there are 2 divisions or types. The first one is excitation monochromator and the second one is emission monochromator. Then the third component is sample holders. In the sample holders are like the rectangles. Cuvettes are made up of glass or quartz materials. The cuvettes are made up like that. Then we move the fourth one, the detectors. Then the fifth one is readout device. Here in the picture we are observing the instrumentations of fluorescence spectrophotometer. The instrumentation consists of the light source at the first, then the light moves into the excitation monochromator, then the sample holders, then they move into the emission monochromator, and they move to the detectors where they detect and analyze the sample and gives the signals into the readout device. Then we observe the light source. This light source is very important for the analysis of sample. Then the monochromator. There are 2 types of monochromator, the emission monochromator and excitation monochromator. For the first, we go about the excitation monochromator. In excitation monochromator, it allows only the radiations which excites molecules or atoms only. Then we go to the emission monochromator. It passes radiations only emitted the sample molecules to the detectors. Then we go on to the sample holders. I already told that the sample holders are the cuvettes, are made up of quartz or glass. Then it could be a square or cylinder in shapes. The sample holders are generally used for the UV range samples. We use the quartz sample holders or quartz materialistic cuvettes. Then above the UV region, we use the glass cuvettes. Then we move on to the detectors. The detectors, it will convert the light energy into the electrical signal that are displayed on readout device. Then the photomultiplier tube is commonly used as detector in fluorescence spectroscopy. Then the readout device. After the analysis of sample, the output current from the detector is displayed in the readout devices. This is about my topic. Then the application of this fluorescence spectrophotometer. The first application is X-ray fluorescence is a useful for the analysis of metals and non-metals with atomic number of greater than 12. With special equipments, elements of atomic number 5 to 11 can also be displayed and analyzed. From this, fluorescence spectroscopy. The qualitative analysis can be carried out by measuring the angle of diffraction of the fluorescent X-rays. The quantitative analysis can be carried out by measuring the intensity of fluorescence. In agriculture, the technique is used for the determination of trace elements in plants and foods. Then the next point, the X-ray fluorescence is used for direct determination of sulfur in proteins. The X-ray fluorescence is used for analysis of ores and tailings and concentrates and drilled crops. In the next point, in the rubber industry, the detector or orinations of the vulcanizing element sulfur are be done by X-ray fluorescence. In space technologies, the analysis of new alloy and ceramics can be carried out by X-ray fluorescence. This is all the topics and the content followed and we studied under the fluorescence spectroscopy. Thank you.